Good morning, ladies and gentlemen. This is Robert Conley on Robert Live / EI-1. And this morning, I am going to be talking to you about the current. I'll talk to you about some things that are happening currently and what I can see the way things are going to be going towards in the future. I have a few times given information about things that I think about because when I go to sleep, my mind, it doesn't stop, seems like sometimes. I just keep on going and I get information. People send me information, which is very much appreciated. And once in a while, I will wake up in the night and I'll turn on my phone on Facebook and there's an advertisement or something that comes across and it leads me someplace else. And I see some things that a lot of us don't see. I am attracted by some science stuff that a lot of us are not attracted by. And so when I bring this information in and I show it to you, it appears that I am more educated than what I am, or makes me appear smarter than what I am. I'm just paying attention. I'm just seeing things that's going on. I'm listening to things that's going on, and I connect the dots together to make sense out of what it is that I see. So today's show, as I'm talking to you, and as we're going through this show today, what I'm going to be talking about today is Judy rockets to the moon. What does Judy rockets to the moon mean? Because I've said that a number of times on my shows, on in my little ads that I place out there. I've said Judy rockets to the moon a number of times. Well, Judy rockets to the moon is a line out of an old song that I used to hear when I was in middle school, I think, because it's from the late 60s and it's Ball of Confusion was the name of the song, Ball of Confusion. And that line was in that song and it's stuck in my head. Judy rockets to the moon. And then it also said right after that, kids growing up too soon. I believe both of those things, kids growing up too soon and Judy rockets to the moon. Well, now Judy rockets to the moon in my head is Elon Musk and Dogecoin going into outer space. Judy rockets to the moon. Dogecoin, cryptocurrencies, because once they start colonies on Mars is where it looks like the first colony is going to be started. They're going to need currency as we always need to purchase and trade. And so the currency, I believe, that's going to be there is the Dogecoin, because if Elon Musk is going to start the colonization on the other planet, Mars, the red planet, then he's going to control what's going on because there's no president there. There's no United Nations there. It's going to be Elon Musk. So, I mean, a lot of people haven't thought about it that far in advance. Oh, so Elon Musk is going to go and start a colony. Well, there are no laws there. There are no rules there. And so whatever Elon Musk says goes. He's going to have a police force, or maybe not. He may not have to have a police force because everyone going there is going to be accountable for themselves. Morning, Kay. Everyone going there is going to be accountable for themselves. And as they're accountable for themselves, they're going to have to do what's necessary in order to make the place become habitable. And so in doing that, that means that everybody there is going to play a key role into developing that planet. If that happens, everyone that goes there, there's not going to be anybody sitting out doing whatever they want to do, going to a coffee shop, getting a cup of coffee, sitting around talking. That's not even going to be available. So everybody is going to have to play their part. And I can see that if they don't play their part in developing the new planet, they're going to be shipped back to this one. So Judy rockets to the moon now includes the Doge coin, not just the people, but the Doge coin. And the Doge coin, as I've told people before, I believe is going to become more and more popular. It probably is going to be a mainstream cryptocurrency that's going to be accepted in many places. It's already accepted in, who's that? The basketball team down in Houston, I believe they accept Dogecoin. And I just saw an article yesterday making way for Dogecoin to be accepted at Walmart as well. AMC Theaters, I believe, accepts Dogecoin. And so it's growing more and more popular. So Judy rockets to the moon. That's not the only thing that's going on. Okay. Judy rockets to the moon with the Dogecoin and the rockets. Let me see if I have the right video that I'm bringing onto screen here so that I don't get out of place here. I've got a video that I want to show you, but I've got to make sure that I've got the right one in place. Let me find the video so I can show you what it is that I'm going to be talking about here. Because right now the rockets that are being used to go up into space are being manufactured in different locations. And the rockets that Elon Musk is using are being manufactured down in Texas. As they're being manufactured down in Texas, Elon Musk is wanting to start a city down there, and that city down there in Texas would also be using cryptocurrency. Well, here's what's going on right now: 3D printing, cryptocurrency, and rockets. 3D printing, cryptocurrency, and rockets.
This is the world's...
Now, this is a sped up video here in the beginning. Okay, what you just saw was the beginning of a rocket being printed with a 3D printer. And this 3D printer is welding a rocket, a 3D welded rocket made out of aluminum.
This is the world's largest 3D metal printer. It was built by Relativity Space, a startup that aims to print an entire rocket, including fuel tanks and...
3D printed. Okay, 3D printed. You can see how long it is. If you look down and you look at the size of that ladder, that's a 5-foot ladder there, down to the right end of the fuel tank.
Tanks and rocket engines in just 60 days. I'm like looking inside a 3D printed rocket that is actually going to go to space. This giant hunk of metal. It's unbelievable. This video is sponsored by Omaze, offering you the chance to win a trip to space. More about that at the end of the show. There's a lot of UV coming off the welds. You can film it, but don't look directly at it. You get sunburned fast, so it's like you're suiting up to go in a volcano. All right, we're going to go in to the...
When they go in here, listen to how long it takes to print one of these things.
All right, so yep, just
and afterwards.
We are in the printer. I can see it over there. If we walk around here, we can get up close. So that's the wire melting and the print head moving around. So that's the plasma discharge, and it's hard to tell, but it's doing things at every couple milliseconds. It's actually changing the electric waveform, which is how it's controlling the depth.
the thickness of the aluminum that is going down. You can see how thin the skin actually is for this rocket that they are printing. It's not very thick at all. I think it's way less than a half-inch thick. Watch how this thing looks.
So that's the wire melting and the print head moving around. So that's the plasma discharge, and it's hard to tell, but it's doing things at every couple milliseconds. It's actually changing the electric waveform, which is how it's controlling the deposition so well.
Do you know the temperature of it? Like, is it just above melt temp?
It's just above melting for aluminum. Yeah, probably a few hundred degrees above.
The melting point of aluminum is 660 degrees Celsius, so the whole body of the rocket is effectively melted together one tiny bit at a time.
All the raw metal for the whole rocket that's printed is this. It's we kind of joke it's like Charlotte's Web, like a spider silk, but this is an aluminum alloy that's on a wire spool. We actually print about 10 inches a second. So this wire is really going super fast, and then the combination of lasers and plasma arc discharge are working to melt both of them together at the same time.
So where does the wire come out?
So it's right there, and then the electric arc discharge happens right at the tip of the wire too.
This is a camera?
Yeah, that's a camera.
But why would you want to 3D print a rocket? Is it just because we can? It's funny to me that you had this experience with 3D printing where you're like, oh, 3D printing is clearly the future. Whereas I feel like a lot of people's experience with 3D printers, as mine has been, it's like incredibly frustrating. I feel like 3D printing is that thing that seems like it should be great, and yet whenever I try it, I don't get a result that I'm happy with.
Yeah, I know. I can tell you, we had plenty of experiences the first couple of years where we ended up with a pile of metal and it didn't work.
But there are actually good reasons to 3D print a rocket. A rocket has 4 major systems: payload, guidance, structural, and propulsion. The bulk of the rocket is made up of the propulsion system, including the propellant tanks and the rocket engines. Cryogenic fuel and oxidizer are pumped through an injector into the combustion chamber where they react, releasing an enormous amount of heat. This causes the exhaust gases to expand, exiting the rocket nozzle at high velocity. The faster this exit velocity and the higher the mass flow rate, the more thrust that can be generated. So rockets are huge, complex engineering projects, which up to this point...
This is where it all changes, because what he's about to tell you is that NASA, in the construction of rockets, has taken 11 years to construct a rocket. Now, check this out, because it just gives me chills on how quickly they can build a rocket using 3D printers. Just check this out. Listen to this.
Have largely been manufactured using traditional techniques. That means before you can build the rocket, you first have to build the tools to build the rocket. For example, to build NASA's next huge rocket, the Space Launch System, or SLS, they first needed to construct the Vertical Assembly Center, or VAC. This is a 170-foot tall tool for welding together the domes, rings, and barrel sections of the rocket's fuel tanks.
They built that like an aerospace thing, and they had to spin up all these custom tooling designs and validate that those work before it actually starts building the rocket. And they finally got one being assembled on the pad after 11 years of development.
In contrast, Relativity Space, the company, is just 5.5 years old, and they plan to launch their first rocket this year.
I see this as a old engineering style versus Silicon Valley style of build something, figure out what's wrong with it, build another thing that fixes those, right? The difference is I've always done that with software. These guys are doing it with aerospace hardware.
So this is the actual rocket tank structure of what we're going to be launching to orbit at the end of this year. So this actual thing is launching to space. That will go to space. This will go to space, and it's by far the largest 3D printed product really of any type ever made that's going to fly. I think maybe of any type in the world.
But it still looks 3D printed, like you can still see the layers.
Yeah, you can still see the layers. It only adds an extra 5 to 10% of the mass with the roughness. When you actually cross-section the material and look at the machine parts of it, it looks like normal metal. Like actually at this end, this is printed as well. We just machine it afterwards. So it looks like normal metal in the joint sections. Does the surface roughness cause any aerodynamic?
Okay, so they are building these rockets, and they expect that they're going to be able to build these rockets and send them into space. Now, the time that it took NASA to build one rocket ship was 11 years. And what they were showing you is that in the beginning, they had to build the assembly tower and all of the tools that go with it in order to build the rocket. And they took all of that time, all of that money, all of those materials to build one rocket, or maybe another one after they got finished and launched it. But at least in the beginning, they had to spend a lot of time and money and materials to get to the point where they could build a rocket. Well, 3D printing moves all of that tooling and all of that construction down to one manufacturing facility without having to build that tall tower. And they can do it right where they're at with the one machine and not have to have all of those hands and people doing it. And they can do them over and over and over again. So that one was done, and I should say nearly done. That one was nearly done, and they're going to be able to print these rockets because they're going to be printing not just the rocket, but they're printing rocket parts as well. And the number of rocket parts that has been reduced, the number that has been reduced because they're using 3D printing, is they have reduced the number by 100 times. They've reduced the number of parts that go into the rocket by 100 times. That means a lot less figuring things out, except for figuring it out on a computer, a lot fewer hands involved, a lot less mistakes involved, making it safer and making it cheaper. So once these rockets start going up that have been 3D printed, they'll be able to roll them off the assembly line, according to what I understand, every 2 months instead of 11 years. That's enormous. 11 years compared to 2 months. That's enormous. So Judy rockets to the moon. Yes, Judy rockets to the moon and is going to be rocketing to the moon pretty quickly, according to how they are 3D printing these rockets now. Okay. Also, what I wanted to share with you today was some information about how we are not just 3D printing rockets, which is the biggest thing that I've ever seen 3D printed, because 3D printing was just on your desktop or on your tabletop, right? And you could build these little trinkets and these little gadgets and things that you wanted to impress somebody with, and you could do that. Well, now the 3D printer, as I showed you, is printing rockets. Someone's built a 3D printer to print rockets with. Well, here's something that is going to change the way not change the way we live, but change the structure that we live in. This is a desktop 3D printer.
The idea of 3D printing our buildings is nothing new. Faced with a desperate need to construct more homes faster and in a more efficient way, countless innovators have found themselves drawn by the idea of being able to quickly print a structure and have spent years trying to scale the technology. But for all their efforts, that 3D printed world has proven elusive, and many impressive prototypes have struggled to become viable for mass production.
3D printed houses.
But things have just taken a massive step forward in Germany with the completion of the first ever 3D printed home to become fully certified under a national government's building regulations. The impact of this moment for construction and for the buildings we all use could be huge.
This is a pretty large house.
With the promise of cutting waste, reducing time on site, and addressing labour shortages, some see 3D printing as the answer to many of our world's challenges. Originally used for small-scale prototypes, advances in 3D printing have led to the creation of full-scale structures like bridges and homes, and even plans for mankind.
Our friend Tammy Eam used
But while
a
3D printed structures have appeared around the
3D
world,
printer
Canada
at
and
her
Netherlands
local
since
library.
July, which wants to 3D print a quarter of its new buildings by 2030, the technology is yet to take off as a widespread building technique. But the completion of this 3D printed house in Beckham, Germany is set to change everything. Developed by leading formwork and scaffolding firm Perry, experts in its
Not looking like the traditional house, looking like a modern piece of artwork. That's a very nice house. I'd have no problem living in one that looked like that. Don't have to have the pitched roof unless you live in an area where there's a lot of snow. And if you have the structure built strong enough, it can still withstand a lot of snow on the roof as well. So it would be a very nice structure for me to live in, no problem.
disruptive products and technologies department and its project partners. The structure, a detached single-family property, is the first 3D printed house in Germany and offers 160 square meters of living space across its 2 stories. Critically, the structure is the first 3D printed building in Germany to become certified with a national building accreditation, smashing a major barrier and paving the way for larger, more complex projects. Located,
they have it under roof to protect from the sun and from the weather, to allow for the printer to keep on moving as it should, so that it can build the house on a continual basis without stopping because of the weather.
just outside the city of Ulm, Perry's team is now working on the largest 3D printed multi-family house in Europe, with 380 square meters of living space divided into 5 apartments across 3 levels.
So how did Perry get into the world of 3D printing?
So 3D printed houses, but you know, there's a thing about these 3D printed houses that is making them obsolete before they even become mainstream. They're becoming obsolete before they even become mainstream. How is that happening? Well, there's even a newer technology. And as most of you don't even know about 3D printed houses, where the printers and one person manning or womaning the printer can print all of the walls of one house, 1,000 square foot house, in one day. In one day. And then you just have to finish off the inside, finish off the roof, add the windows, doors, all that stuff, the finishing touches. And in 30 days, you can have a completely finished home. In 30 days. Now, I know that there are some places that are building houses pretty quick, but they're bringing in prefabricated walls that were manufactured inside of a factory someplace. And that's increasing the speed, but it's not necessarily reducing the labor, because somebody inside the factory is putting together walls, unless they're using robots. And then when the walls come, there are people that have to assemble these walls. And if it's raining, no work is getting done. So in putting up these 3D printed houses which is a fantastic idea, the technology is changing. And as this technology changes, it's increasing the quality of the home, as well as reducing the cost. And in the reduction of the cost and the higher quality also comes fabulous speed. This company in Las Vegas, which was an idea that I had when I started building the tiny home and I started getting people together to help me build it. This idea that I had, someone else was working on the same type idea, but it was better than the idea that I had. And they had been able to formulate it, make it work. And now this company, inside of 2 years, which is when I started the tiny home a couple years ago, inside of 2 years, has a waiting list of 100,000 units. And they have 50,000 people that have given them a deposit waiting on their units to be manufactured. When it's normal and when things are moving along as fast as they need to, because right now this company is not keeping up with the manufacturing demand, when it's moving along as it's supposed to, or as they designed it to, I could order a house today, have it delivered to my property, set down onto my foundation, have the utilities connected, unfold the house, lock it in, and I will have my house in a week. 1 week. And it would be structurally stronger than what you just saw with the 3D houses. 3D houses. Okay, check this out.
Look at that. I mean, right there looks more like an iPhone packaging than a house. Is that how you expect your house to run? Frankly, I think it looks more like an iPhone unboxing here. This is the boxable casita. It is a 20 by 20 room module that can be deployed and set up in less than an hour. If you look at modern building construction, it's really not modern at all. Mostly it's guys using hand tools building one at a time on site. And the cool thing is, when this unfolds from the 8.5 footprint, it's done. Not including the couch and the bed, those you'll have to bring in after, but this kitchen, bathroom, electrical, flooring, HVAC, everything is done in the factory. So that means super easy install on site. They can be deployed in a permanent manner, or they can be pulled up and brought somewhere else later on. There's a bunch of different reasons why building construction is not compatible with the factory. The first big one is the shipping.
Galliano, what are you doing?
All right, here we go. You think this can tell the boxable? It's not rated to.
No, not at all.
Houses are very big. It's not cost effective to ship them. One of the big problems with modular construction is they're too big to ship. So if you look at this, this is one of our units. It's actually folded up to 8.5 feet wide. And then it unfolds to the big 20-foot building. Everything we're doing here is to try to engineer a standardized product that can be customized out in the field and gives builders the ability to build custom homes while still being able to take advantage of factory efficiencies that we get by building standardized products with repeatability.
So you see how convenient this is for building a house in a factory that folds up, is in a box on a trailer, if you had it on a trailer, and then deliver it or move it as you need to move it. And I mean, this is just so interesting. This is just so interesting because as I was building the tiny house and I was trying to figure out how it could be done so simply, I was figuring modules going together and putting the house together. I envisioned a person walking in the front door, sitting down with the salesperson, telling that salesperson what they wanted in the house, and then the factory going with a forklift to go and pick up the modules that they wanted and put them together and then drive away and deliver that tiny house. But this is so much more convenient, so much more efficient, so much stronger. I mean, it's just a fantastic method to do this, to build a house. And people are thinking, well, I don't want to live in one of those. Well, maybe you don't, and that's fine. But we have millennials that will live in them. We have some older people that will live in them. There are a lot of people that don't have a problem with living in a tiny house. We have a lot of people that don't have a problem with living in a tiny house. I have a friend, actually the guy that got me involved in to building the tiny house, went and lived in one last week or the week before, just so that he could see what it seemed like to live in, what it felt like to live in a tiny house. And he did it and he liked it. He lived, I don't know how long he stayed there, but he said he liked it. It was convenient and it was everything that he needed. So things are changing, technology is changing. And if we do not grab hold of the technology, the younger people are grabbing hold of it. They were born with a telephone in their hand, a laptop computer in their hands. They know what's going on, and they are going to be changing, or I should say, they are going to be living their lives the way they want to live them. Okay, so Judy rockets to the moon, 3D printing, 3D modules up in space, and for living quarters, and 3D houses being printed here, and now robot built foldable homes that can be ordered and delivered in a week. Technology has a beginning, but it has no end. Technology has a beginning. And as things keep on moving and moving and moving, I was saying cryptocurrency, the Dogecoin, will be used on Mars. It will be used in the Texas city where Elon Musk builds his rockets, where he is building the city. It's currently a village. He has already applied to make it a city. And when that happens, he's going to be using Dogecoin as the currency in that city. People are going to be using Dogecoin more and more in order to purchase the things that they want to purchase, and trading back and forth. Now, as Dogecoin and all the other cryptocurrencies are becoming more and more, closer and closer to mainstream, people still don't know what cryptocurrency is. People still don't know the uses for it. People still cannot grasp looking at their currency being a code on a piece of paper or a computer screen or their telephone and understanding that it's money. They're used to they were fooled. They've been fooled all along because they call the currency, the dollars that we use now, they call it paper. Well, it's not paper, it's cotton. The dollars that we use are made out of cotton. That's why if you put one in the washing machine, it doesn't disintegrate. because it's made out of cotton. It's not made out of paper. So as money changes from rocks to coins to metals to cotton and to plastic, well, now it's changing into something you can't touch, something you can't smell. It's changing into a code that you keep on your telephone or in your cryptocurrency wallet or on your computer, because there's less than 7% of the money that we use is the cotton dollar bills anyway. Less than 7%. Most of it is transferred through electronic means, or well, it's still through electronic means if you use your credit card, because a credit card has no value. It's what it's connected to that has the value. And it's connected to the bank account or the loan account that you have. So it's not the card itself. It's not the magnetic strip. It's the account that the money comes out of. Okay, that's where the money is at. So if somebody steals your card and you lock it down, the card's not got any value. It didn't have any value anyway. It was the connection to the account. And that account is nothing but wired money. It's numbers sitting there on a computer someplace, and we use them in order to buy and sell. That's what it is. So cryptocurrency is now being used by major insurance and investment firms, and it's being used all over the world. And the one company that Jamie Dimon is with, Chase Bank, and 3 years ago, Jamie Dimon told everybody on national television, don't invest in cryptocurrency, don't invest in Bitcoin, you're going to get taken. And then who went and bought millions and millions and millions of dollars worth of Bitcoin and is trading it daily? Yes, moving it around daily and making money off of it. So as things change and as we move along, and technology, my dad told me technology has a beginning, but it has no end. Here's more technology. And this is what I was telling you a couple of years ago when I was talking about graphene. When I was talking about graphene, now it's moving into the mainstream of manufacturing. And what I said is that if the right engineer with the right design would create a personal flying machine out of graphene, the skin would become a huge solar panel absorbing the sun's energy. The motors made out of graphene would be lighter weight to propel the craft. And once you got to your destination, you could fold the thing up into the size of a briefcase, as George Jetson did, and walk into your place of work or your home. That's through the right engineering. You just saw that with a house. Fold it up, move it to wherever you want it to move to. And now these companies are starting to understand the benefits of using a graphene or graphene type material that's lighter weight, that stores and moves energy faster to make their products more superior than the previous. This is a giant step to cleaning up the earth.
The biggest roadblock to widespread mainstream adoption of electric vehicles is range. We're typically seeing 300 miles or less for most EVs on the market, which is more than enough for daily driving, but still not enough to put range anxiety to rest. Because of the battery pack's incredible weight, there's a balance that EV makers have to find. Less weight means less energy needed to move the car, but also less overall range. Add more battery to get more range, and you've increased the weight and the amount of energy needed to move. But what if we could take some of that weight out of the equation? Imagine a car that has no battery pack because the car's structure is the pack. Let's explore massless energy storage and how a recent breakthrough could have a...
Okay, what you're looking at right now is a graphene type battery. It stores the energy and it moves it faster than copper moves the energy. Okay, it receives the light energy and then can store it as well into a battery system that is connected to the solar panel, which you're looking at right there, basically. And then it will be able to move the energy, store the energy, collect the energy. That's what you need for a propulsion system such as electric motors. Okay, another trick. Long ago, and these people that are muscle car lovers and that talk about automobiles and stuff like that, the old time 60s, 70s, you know, even 80s, and there's still some of these people around. They say it's got a big motor in it. Well, the motor that's in a car, a gasoline powered car, the motor that's in the car to make it move is the starter, the electric starter. The engine, which is an internal combustion engine, is the propulsion unit used to make the energy and drive the car. A motor runs off electricity. An engine is internal combustion. So when you hear some, and they call them motor boats, well, they're not motor boats. They're internal combustion engine boats. Okay, so there's been a lot of misunderstanding about the things that we use in everyday life. And there are things, and actually I was going to post this yesterday and I forgot about it. What are things that we say that are not really things that we are saying? What are some of the things that we say that really are not some of the things that we are intending to say or should be saying? Like, shut the front door or get out of here. We don't mean for a person to literally get out of here, but people say things, they become mainstream, they become adopted. And so then the understanding is there, but it's a false understanding. Just like the word racism is false. There's the human race. If you have a problem with another person because of their skin color, or because they live in a bigger house, or because they use drugs, that's prejudice. It's not racism, it's prejudice. Okay, so the terms that we use, they're not true terms, and it's causing mass confusion. Mass confusion. But it's only causing mass confusion with the people that are less educated and don't know the reality of what is going on and what's being said. So as you're looking at this solar panel, energy cell, whatever it is that they call it, that receives light energy, distributes the energy, and also can store the energy, it's much, much lighter weight, which can reduce the weight of the electric vehicles and also give them more energy. If you reduce the weight, the amount of energy necessary to move that vehicle is going to be less. That means it can go further or go faster.
Dramatic shift in how we store energy in our phones, planes, cars, you name it. I'm Matt Farrell. Welcome to Undecided.
Okay, so in making these things work, in us getting to the point of making our lives easier, our lives better, our lives cleaner, our lives more efficient, and getting to that point, we have to accept the new technologies. We have to believe the new technologies are good for us. And science controls our lives. Science does. If you don't want to believe it, that's fine. And people say, okay, well, I believe in God. God controls me. Well, I understand that. And everyone has their choice of their religion. And I'm not going to dispute that at all. If God is controlling your life, then that's fantastic. And if you solely and totally believe in God, then believe that God is going to take care of everything that you need taken care of. But you're living in a science world. You put on clothes created by science. You eat food that's manufactured with the aid of science, grown with the aid of science. You sit in a seat, you drive in a car, you eat off of utensils and dishes. All of this stuff is science. Everything you see besides nature is science. And everything that's in your life besides love is science. Science and technology is moving us forward. We just have to adopt it, adapt to it, and use it to the best of our advantage. Hopefully it's all good, and move on, because things keep on moving. And as they do, then we are just going to have an easier, more simple life, whether you like it or not. And now I'm going to give you a piece of Double Cash Daily Mansion Club. I'm going to tell you that I have reached another level. So now I'm halfway to the goal. I'm moving a little bit faster. I'm expecting, as I've always done, expected to move faster and faster. And it's because of technology. It's because of science. And it's because of the science that I've created. Okay, it's not big, but it's big enough for me. And then there's other people paying attention to it now, and I'll do my best to take care of it and take care of me so that I can get to where I want to go. And if they want it, then they have to pay for it, or they have to work for me or with me and use this science to win money at the casinos. So I've reached one more level where I'm at $50,000 won and heading to $100,000. And if all works well, then the pace will be sped up. And as it's taken me 3 years to get to the $50,000 mark, I expect the next $50,000 to come in less than a month. This is Robert Conley on EI-1 on Robert Live. I'm gone, y'all.